All right. All right, students. I had to unmute myself there. Um, this is chapter 8, Factorial Designs, and you're ready for it because you've been working really hard and you've understood control considerations up till now, what an experiment can do for us, and then last chapter, single factor experiments and the difference between groups and within groups. And with that knowledge, we are ready to jump into the last chapter on experiments before we get into some descriptive and correlational techniques. But this chapter, if you're flowing to this point in the quarter, I think it's sort of the next step. And it's a little hard to get, but it makes some sense. Um, if last chapter was a struggle for you, or the previous 3 chapters about experiments, this is going to be challenging. Here's what I'm going to do. I don't have much. I have 1 page of notes, and I want to talk through some things for you. And I want to do it in a way that I don't want this to fall over. Can I do that? Okay, perfect. Okay. So I want to do this in a way that comes at some of these things in a little bit of a different way than your textbook does. Okay. So here's what I want to start with. Nothing changes here. Okay. I'm going to give you some ways to really help yourself or keep yourself from making an error. Okay. Nothing changes here from what we've already started to do. Every time you see an experiment, no matter how complicated it is, your job is the same. Figure out what the dependent variables are. What's this about? What are we trying to measure? Then figure out what the variations are, the independent variables. If you can figure out what the independent variable is or are, and the dependent variable is or are, then you're good. Then you're going to be fine. And that is the challenging part. When they start throwing around lots of variables, pulling out the independent variable versus the dependent variable is a skill. I think you're ready for it. You've been doing it up till this point. It's now just a little more complicated. You've got to ask yourself, what are they interested in? That's why we come back to that research question. What is the research question and hypothesis here? Because that will help us determine what those variables are, because it can get complicated, right? So we pull out the independent variables, we label them, we pull out the dependent variables, we look at those, we look at the scale for the dependent variables, and then we're ready to figure out what this thing is. Now, when you pull out those independent variables, you have to ask some questions about them. Obviously, you have to ask yourself, is it a subject variable or not? Is it a manipulated variable? Is this a subject variable or is it a manipulated variable, right? And then you have to ask yourself, is this a between groups variable or a within groups variable? So are we measuring people against themselves for this variable, or are we measuring people against others? And it is per variable, right? Because if you are measuring some people between or one of the variables between groups and the other variable within groups, you've got a, finish the sentence for me. What kind of factorial design do you have? Hopefully you said mixed. You have a mixed factorial design. This is hard to get our heads around. So let me just give you an example, okay? If we wanted to figure out, let's say we wanted to see how much alertness does somebody get from drinking a Coke versus a Pepsi, depending on whether they are a man or a woman. Okay, so the dependent variable is alertness. The independent variable, the first one, is Coke or Pepsi. The second independent variable is man or woman. Now here we have a subject variable and we have a manipulated variable. Okay, the subject variable being man or woman, the manipulated variable being Coke or Pepsi. Okay. Now people are going to get randomly assigned to Coke or Pepsi, but we can't randomly assign a subject variable. Anyway, so that is a P by E because we've got a participant variable, which is the subject variable, and we have an environmental variable, which is the manipulated variable, Coke or Pepsi. So we've got a P by E design there, but we also have a mixed design because we are going to measure people, different groups of people, and we're going to measure them against their own preferences or against their own preferences. I guess it wouldn't be preferences. They're alertness measures for Coke and Pepsi. So the men are going to get tested in both trials, and the women are going to be tested in both trials. Okay, we could do this differently. We could do this without a subject variable. We could do this with, let's say, do people who either get randomly assigned into 4 or 8 hours of sleep, like getting 4 or 8 hours of sleep, um, find more alertness with either Coke or Pepsi. Okay, so we're still measuring alertness. That's a dependent variable. We are going to then take our group and we're going to randomly assign them into 4 different conditions. This is a 2 by 2 factorial. And so some folks are going to be, I'm sorry, we're going to put them into 2 different conditions, right? The 4 hours of sleep or the 8 hours of sleep, but within that, they are going to get both Coke and Pepsi. So we have a mixed design here. They're going to get, we are taking that the first independent variable of 4 or 8 hours, and we are going to distribute people randomly into those 2 groups, right? And so 4 to 8 hours, but then they get both levels of the other independent variable, which is the type of soda. Okay, and so we have a mixed design there, but there's no subject variable, so it's not a P by E. Okay, because there's no person variable there. Okay, so in one, we just switched. We did 2 examples just now. In one of them, it was a subject variable. It was men versus women as we're looking at this, and so that was the P by E. And then in the other one, we just switched out whether somebody gets 4 hours of sleep or 8 hours of sleep a night, and we would control that in a laboratory setting, and we would then not have a P by E. In both cases, it would be mixed. Why? Because we have one of the variables is a between groups, and the other one is a within groups or repeated measures variable. So that's the mixed. Hopefully that makes some sense to you. Nothing changes, right? The way we get to that. Now, it's hard. It's easier if you're writing this out, right? So make your list, independent variables, dependent variables. So this is an independent manipulated variable, and then you get down to the next one. This is a subject variable. Now with that information, you can tell what you're working with. P by E, not P by E. Is this a mixed design? And that will tell you everything you need to know as long as you have labeled things correctly. Then you can ask it. Very rarely can I can't do it. Could somebody just read through a study and know what it is? I mean, very rarely. So not without making mistakes anyway. And so this does just need to be worked out, and you have this skill, right, to use that formatting that I've asked you to do and pull these things out. Okay. Let's see, where else do we want to go here? Drawing a matrix is, let's talk about drawing a matrix, and then we'll talk about main effects and interactions. Okay, so drawing a matrix should be pretty straightforward for you in a factorial, and it's pretty easy with 2 levels, a little more complicated with 3 levels, or I'm sorry, I should say 2 independent variables or 3 independent variables. Okay, I shouldn't have said levels there. So a 2 by 2 factorial is pretty straightforward. A 3 by 2 by 2, or let's say a 2 by 2 by 2 factorial gets a little harder to draw the matrix out. So then you'd have a box of 4 and another box of 4, right? And that would be what the matrix would look like for a 2 by 2 by 2 factorial, okay? 3 independent variables with 2 levels each. So much of this stuff is better done probably through writing, and I just don't have a board with me. So, and it wouldn't do well on this Zoom anyway. Hopefully you are tracking me there. Okay, so let's just think about a 2 by 2 factorial, because that's what your textbook helps you to graph, okay? Like a 2 by 2 factorial where the dependent variable, whatever the measurement is, those numbers, those quantities are in the 2 by 2 factorial matrix. So we call that a matrix. If it's a 2 by 2, it's going to have 4 scores in it. It's going to be your dependent variable scores for each of the conditions. All right. So each of those 4 squares is one condition. So there are 4 different conditions. And just for language sake, we've got 2 independent variables, each with 2 levels. So variables, levels of each variable, which is going to be important in a moment, and then the 4 conditions that makes 2 by 2. 4 conditions that include every possibility of both independent variables. And that's just multiplication, right? 2 by 2. All right. So once you have that matrix, your textbook shows you how to graph out of that. And you just need to follow it step by step. The reason why it is so important for you to graph, there's probably lots of reasons. Here's the one I want you to know. That graphs will show you immediately if there is an interaction. Looking for an interaction in a factorial matrix, in that 2 by 2 factorial matrix, those 4 boxes, is very hard. I'm not good at it. I need to put them into a graph and look for those lines crossing. If those lines are crossing, always an interaction. There's an interaction there. So strangely, I find interactions by looking at the graphs and seeing if those lines cross, but I find main effects through simple addition on the factorial matrix, okay? So I never look for main effects on the graph. I think they're really hard to see on the graph, but they're easy to see in a factorial matrix. So here's the thing about the main effect. When we ask, is there a main effect? We've got 2 independent variables, right? Let's say we've got men and women in Coke and Pepsi, okay? We got 2 independent variables. We are just asking, like, a main effect is actually a really simple question. It's like for sex or gender, is there a main effect? And all we're asking is, was there a difference if you were man or if you were a woman in the study? Was there a main effect for gender? So how would we figure that out? Well, we would just add up the 2 categories or the 2 squares for in both conditions in a 2 by 2. So let's say that yep, I'm not going to be able to get away from it. I'm going to have to do this. Men, women, Coke, Pepsi. Okay. Okay. Men, women. Oh, wrong side. Men, women. The main effect is just blocking out Coke and Pepsi like they're not even there, and adding up those rows, the rows. So it's on the top row, it equals 12 plus 10 is 22. And on the bottom row, 22 plus 14 is 36. Because those numbers are different, there is a main effect. It's that simple. Okay? 12 plus 10, 14 plus 22. Those numbers are different. If there was no main effect, the top row would add up to 22 and the bottom row would add up to 22. Or conversely, the top row would add up to 36 and the bottom row would add up to 36. That would be no main effect. But because they add up to different numbers, and here's how I'll say it for this as we're looking at here's the hard and fast rule for this class. If the numbers, just round to the nearest one number. So let's not worry about, because if we get into like time and milliseconds or something like that, it gets more complicated, but just round to the nearest one number. So in this case, if it was like 14.3, we'd just round down to 14. Okay. And that's how, if there's any difference in the rows as you compare them to each other, that's a main effect. Okay. Main effect for Coke and Pepsi. Well, we just do the opposite. Just block those off. And now we're just adding down the rows. So here we go. 14 plus 12 is 26. 22 plus 10 is 32. We have a main effect for soda. All right. And so that's how we get main effects. Very hard to see interactions here. You need to graph it. I don't even know if there's an interaction there. I'm not going to do it right now, but okay. So that is, I think that's really straightforward. If you didn't get that, you need to rewind it, watch it again until you get it, because it was all right. Okay. So find your main effects on the factorial matrix. Find your interactions on the graph. You need that skill to be able to graph back and forth. It's pretty easy. You can just practice. Take 30 minutes and make up some scenarios like I just did. Make up some scenarios where you're creating P by E designs, where you're creating mixed factorials, and then move them from, make up the data, the dependent variable data, move from matrix to graph, back to matrix. Give yourself some random graph where it's on a scale of 0 to 43, and you can put the lines and the comparisons on the graph, and then just so the x-axis is, the y-axis is goes to 43, and the x-axis goes 1 to 10, and then go ahead and put some data lines on there, and then move those over to a factorial matrix. Go back and forth. Try it again and again and again. Overlearn it. That's the only way you're going to get it, is overlearning it. You may wonder, like, why would I need to do this right now? Because I am going to ask you about this stuff on the final exam. I am going to have you go back and forth to see if you have developed that skill. So do it now and learn it. Okay. Let's see what else I want to talk about. Formatting for application questions. Just make sure that you're following my formatting guidelines for all the application questions. It's really important now as we get into this, and you need to label all those parts of the independent variables. I think that's all I'm going to talk about in this chapter. So I hope it was helpful. I hope it was, it's nice to get things after you've struggled and read through this and done some work. It's nice to get things from a bit of a different perspective, but really it is that easy. This is complicated stuff, but it's all very systematic. So I hope that this has worked for you. And if it hasn't to this point, I hope by the time we see each other and get to talk about it some more, or you get to ask questions here and get things cleared up for you, that you will get it. So thanks so much for your time, and I will see you all soon.